Welcome everyone, good afternoon. I'm very happy that you are here. I'm pleased to have the opportunity to speak to you. This is my third year in a row being here, so it's kind of tradition now. And so this is the third time I want to look back a bit, and you see here the word roadmap, and I want to give you a bigger picture of what we've presenting the last 3 years and why I brought what I brought this year. So I want to give you a bit of more a story, how things belong together. HIMA has spoken about safety for 50 years now, and we have started to speak about security quite a while ago for good reasons. I don't have to motivate that anymore. What we formally put a lot of effort in is claiming that or stating that we think it's very important that process control systems and safety systems are properly separated for good reasons, for safety reasons, and this we know since long, but also and much more for security reasons, and also this we know since long. We have been stating this for quite a while, and this is of course still very, very true. Safety systems and control systems should be diverse and separated. This is still true. In 2018, my first time here, we presented something called the Security Environment for Functional Safety. And what that did is it explained how we, in the core of our safety controllers, try to implement security in the best way we can. And you know, we've been around for 50 years and programmable systems for 40 years or for 35 years. And of course, when we began, we didn't build in security from scratch because at that time it wasn't a topic. But we got a lot of tailwind from the way we implemented safety. And this is something we have been building upon and explored a lot. And that resulted in something we call the Security Environment for Functional Safety. That was 2018. In 2019, we presented you what we call the Smart Safety Platform. As you know, we have 4 system families of safety controllers, and since last year, we are able to put them into one, so to say. So they don't differ very much anymore. They run the same engineering tool, they run the same firmware, they run the same communication protocol. That means no matter how the history of that family started, we have run now the same security philosophy and implementation in all of them, in any of them. So customers can actually do whatever they want. They inevitably get the same level of security. And I think this is very, very helpful for us and for customers. So they will never be locked in one of the families. Now, we kind of cared for the core of plant safety, which is the safety system. But inevitably also have to look at the periphery of that system and how to deal with that periphery. And this is one aspect of this is something I want to talk about today. And that's the topic even for the next year. So if I'm here next year and the year after, we will continue to talk about how to secure the periphery of the systems. It's not enough to secure the core. It's trivial, but you also have to secure the rest of it. And that has to be done properly. And what I showed you, no, sorry, one more slide before that, is another view of that. You have the safety system and the basic process control system. They need to be separate. You need to do the security within the safety system properly. And we can run any of our families doing that. That's what I just told you. But now, here comes the reason why the periphery is important. We can't lock our systems in because we want to do more with our systems, and even that is not very new. First of all, data must get out of the system. Data needs to get out. This is where the smartness comes in, right? Whatever you want to do smartly, you need data for that. So it's diagnostic data, it's configuration data, or it's engineering data, whatever you want to do with it. And we all know there are good reasons to use that data for something. So it needs to get out in a secure manner. This is where firewalls, data diodes, and so on come in. On the other side, you also need to get in data. To make use of the benefits of modern technology, you need to access your plants somehow, even remotely, easily, but also securely. And the thing I want to talk to about today is remote access. A few years ago, say like 2018, if you had asked me, will we ever see a remote access to a safety system in the process industry, I would have claimed never. We will never see it because I don't believe remote access systems are secure enough. Today in 2020, I have to revise my mind or my opinion, and I think the opposite is true. You can do it if you do it properly. And that clause is very important. You shouldn't do it if you're not certain that you can do it properly. So this is what we want to do, and those yellow arrows is things that will keep us busy for the next years, quite a while. And this is where the money is. We're making use of all smart technology, but this is also where the risk is if you don't do it properly. You saw that slide last year, you might remember. Last year we announced a partnership with a small German company called Genua. This is kind of we found ourselves like brother and sister. We've been doing what we do for 50 years, and it's the safety. Genua is a small company that hasn't been done anything else than security. And they are really, really good. And the reason why I can say that is that the German government actually bought that company because they thought we need to secure that knowledge for the German government. So they deliver a lot of technology for NATO and all the military applications, but as well as for governmental applications. So they run this high security stuff that governments have to rely on. And we thought, hey, that might be a good partner for us. Let's use their stuff in an industrial environment, which also was new for them. And what I'm going to report today is one of the first things we do together. And this is why I can say remote access can be done if it's done properly. By the time we have built up quite a consistent and comprehensive security portfolio, it's a separate press conference for each of them. And of course, I don't want to give you details on all of them. Pretty self-evident is firewalls, is data diodes, is data gateways, and so on. This is stuff we use, and we use for our service people. Something I talked about 2 years ago is the engineering station. This is the most vulnerable part because the engineering station opens every gate into the safety system because this is what it's supposed to do. So if you don't protect that properly, you are in really bad shape. And today we are offering an engineering station we rely on really, really well. And that relates back to Genua, where military operations use the same technologies. So it's not only a hardened laptop, it's done really well. And I stand here and say I would rely this thing very, very much. And we heard, I think, last year that there are process industries that don't allow laptops anymore for service people that are not delivering a certain quality in terms of security. And I think this is right, and it shouldn't be done. Because this is the key to every gate. If you have it vulnerable, it's very, very easy to get in. The thing I want to talk about is remote access, as I mentioned. And let's look at an example. You have a plant here, it's a robot, it doesn't really matter. Something you want to access from outside. There's a service provider that needs to get access to that plant. Why that is beneficial for plant owners is quite easy to understand. People don't have to travel there, you can use it immediately. There's not much more to say about it. We want that. If we can do it, it's very, very beneficial. Now, you have hundreds and thousands of assets in your plant, and you have dozens or hundreds or even thousands of suppliers that might want to access that. So, of course, you can't allow every supplier to bring his own system to access remotely their respective assets. It doesn't make sense. It has to be done by the plant operator or by the company running the plant. And here's how it shouldn't be done. Of course, it needs to go via the internet somehow. There's a firewall in the plant. And through the plant network, you reach the asset you want to do maintenance on. That doesn't work well because you have a lot of vulnerabilities there. One is the network connection as such. It's not encrypted. Of course, this is the easiest case, right? The plant network, once you're in the network, you can get anywhere. This is a large vulnerability as well. And managing the access rights of all the people that want to have access is a menace. Yeah, it doesn't work. So there are better ways to do that, of course. One is encryption, VPN and so on. You can do that. It helps you a bit. Still, you have vulnerabilities within the plant network. So you also need to work on that level. So it has become better on the internet side, but it hasn't become much better on the side within the plant. Now, what's the next thing to do? The next thing to do is to make sure that you can only access the machine you are supposed to access. And for that, you need another box that just guarantees this. This is a hardware carrying a firewall, which is especially good, dealing with the VPN tunnel, so that you can only reach the machine you're supposed to reach. So from here, you can't get anywhere else anymore. But the firewall is still a vulnerability. You also have to deal with that. So the way to do that is, we all know that how it should be done, introducing a demilitarized zone. That means you have a managed access through that firewall. This is the way to do it. And by that, you kind of fulfill all the requests you have. Now, let's look at that in a bit more detail. First of all, when you want to do that, you have an access from both sides of the firewall, one from outside and one from inside, granting the access, and a demilitarized zone, a rendezvous server that makes the connect between the two of them. That's a very simple principle. The devil is in the details. You have to do it really, really well. And what's important here that you must be able to scale that. You can have one provider that accesses two machines. That's a very, very small system. Or you can have hundreds of providers that access mainly all of the stuff in your plant. But both needs to be covered by one system. So unless such a system is not scalable in size very easily, you can never manage all the requests properly. You will always have duplicate systems that disturb each other or that have different levels of security. So one system, and Genua has applications already in large companies. They run all their remote accesses through one system. So it can be huge. It can be thousands of users. And the other important aspect is it's not only scalable in size, it's also scalable in level of security. So when you do it in the basic setting, you're really fine. But you can always add on top of that. Say the remote access side here. Usually it's just an app running a software way of accessing the plant. You can also add a hardware to that level. The same box that is in the plant can also be at the remote service supplier side, if you like. Of course, the level of security comes with a level of, with an increase of cost, of course. So that needs to be determined. That's not a system you just implement. It's a system where you have actually to analyze properly what is the use cases and how detailed should you, or what's the level of security that is appropriate, actually. Let's look at it from another side. Actually, the sides are swapped here. The service provider is on the left and the plant is on the right. You see the basic infrastructure. You have firewalls, you have the rendezvous server that makes the connect, and you have the plant itself. And in the plant, you have the service box that deals with the access from outside. And here is the scalability of say, security. There are many functions that are in the system anyway, but you can add to that according to your security policy. Obviously, in any case, you need some kind of approval from inside for the access from outside. And that kind of approval you can implement in any level you want. You can have a 4 eyes principle, 6 eyes principle, and so on. And of course, the operator can follow everything that happens here. So whatever is supposed to be done for security reasons, it can be done. So it's scalable in size and scalable in level of security. And the technology, a firewall isn't a firewall. The spectrum of quality of firewalls is that large. Of course, also the price. And the principle Genua usually does is they have a minimum amount of software in their firewalls. So everything that is done is on a minimal level because they want to actually analyze the software they write to any detail. So there's no line of code that is not needed, and this is very, very efficient. So they can analyze the behavior very properly, and they know very well what they do. So I showed you a bit what we offer here in remote access. We have the first pilots ongoing in the process industry. The system as such has been proven a lot. I know that SAP runs many of their highly critical financial transactions over the system. So the system has been proven, it works. The remaining part is just connected to the safety system, which is, of course, very, very simple. But what we need to find out, and what we're currently doing with customers, is to see what is the right level you have to scale to for a dedicated application. That requires a lot of experience, and we are building up that experience together with customers currently. And they're very pleased, I can tell you. But there's more to it, and in order to protect a safety system properly, remote access is just one of them. The other one, if we talk about this NAMO open architecture, where you easily want to get data out of your systems, out into the cloud or wherever you want to have it, you need a data diode. And it has been pointed out by the NAMO organization very clearly, a diode is very easy to paint on a PowerPoint slide. But to realize a diode in practice is very, very tricky. And if you're offered a diode, it doesn't mean it's safe, or it's secure. It can be hacked, because a good diode has to include software, because it's not an electrical diode. You need a way back. You need a flag going back from outside to inside telling you actually the data reached its goal. So you need both two-way direction, and you have to secure that properly. So when you ever have to look for a data diode, make sure you pick the right one, because it's a vulnerability if you don't, for sure. So to summarize, open independent integration, segregation of safety and process control systems, this will never go away. We are very, very convinced, and customers actually, they give us right in that. We have customers that ripped out the integrated system and put a separated system into it because they can't afford the risk of security breaches anymore, or they decided to not accept that risk anymore. There are reasons for integrated systems work, but we think these reasons get weaker and weaker every year. Next is a safety system that can secure itself as good as possible. What the state of the art is today, even for legacy systems. We have systems in the market that are still from the 80s, and the customers are happily running them. But of course, they are more and more asking us, okay, the system is from 1988, how can we actually secure it? And they might either migrate to the newer version that gives them the security level of today, or they have to secure it properly. And this is more a service than a technology, because it depends a lot on the vulnerabilities of and how the system around it looks like. But these old systems, they cannot take care of themselves in the way modern systems can. That's self-evident. Last point, freedom of choice. Whatever system family, at least in HIMA, you choose, don't worry. They're all the same in terms of security. You can move your applications from one to the other. We don't lock in people so they have to compromise on security. That is very, very important for us. And the last one, we have to secure the periphery of the system. We have to offer services, because it's a lot of talk here on the conference also that the know-how, especially in smaller companies in the process industry, it's fading out. People go retire. It's very hard to find new experts that know how to build up networks properly, how to really do that. And I think the importance of services, where together with plant operators, we find a solution that is satisfying in all aspects, that is becoming more and more important. So that concludes what I wanted to tell you today. When I'm here next year, I think we will expand on this. We're heavily working on this. I think we have a good portfolio today. We are applying it with many customers today. And I think there's a lot to report in the future. And we'll do that next year. So thank you very much. Last word, I forgot that, sorry. The workshop tomorrow, that brings you a bit into that service world. We are still very, very concerned in the automation of the safety lifecycle. How can the safety system and the services around it make it easier for plant operators to run the safety lifecycle? Because the requirements by the norms and regulations, they get larger and larger. And the need to automate that, to document it systematically and properly is just increasing. And we can't just let it go, so to say. We have to help our customers to do that together. And this is mainly what the workshop tomorrow is about. So you're warmly welcome attending or speaking to us. Thank you very much. I guess there's time for questions. That's how I understood Paul. So in case you have questions, ask them now or come to us later. You're welcome. There's a microphone, if you don't mind, then everybody can, it's coming to you. Everybody can hear you properly.
In the roadmap that you showed, where are your areas of greatest concern today as compared to perhaps 5 years ago?
Which one do you mean? Like,
pick a slide. It's okay.
Second? Or?
Anyone.
Anyone. Let's take this. My greatest concern, I think my greatest concern, that doesn't only relate to HIMA customers, relates to any process industry customer, is the age of the systems out there. What you buy today, I think, is very, very good. What you bought 25 years ago is also very, very good, but it's not the same level of security. So I'm afraid that people don't give it the thought it needs to either migrate or to secure it the way they have it. Because usually people don't want to change. A safety system runs forever mainly, and that's good, and people love it. But now security forces them to do something. It gives them a bad feeling. And if you run your old car, you're very happy with it, but then you realize that the emissions are not as they should be today. So you have a bad feeling about it. And the question is, do you buy a new car or do you try to fix it somehow? And I think the same situation is for our customers. And I think this is where we together need to find ways so you can drive your old car with a good feeling. And maybe the comparison is a bit weird, but it's the best I came up with. So I think this is an area where we should look at, because not everybody applies newest technology, even if we like them to do that. But of course they don't.
Are there any other questions? Thank you very much.
You're welcome. So be welcome to contact us you have our contact details or LinkedIn. We're easy to find. Thank you very much.